Okay, hi guys. So in this lecture, we'll be discussing a new concept, which is heating effect on the organic compounds. So specifically, we'll be seeing decarboxylation reaction. Okay, so let's get started. So we have heating effect on organic compounds, and specifically, we'll be seeing decarboxylation reaction. Okay, decarboxylation reaction. Okay, so inside this we have first beta keto acid. Okay, B we have uh, geminal dicarboxylic acid, and C we have uh, beta gamma unsaturated acid. Okay, D we have soda lime, and E we have NaHCO3. Okay, so decarboxylation is something where CO2 gas releases. Okay, so let's discuss on these are all the type of reactions under decarboxylation reactions. Okay, so let's start off with some example. Okay, so we have something like this compound. Okay, so what happens here is O and H here. So what happens here is this is obviously this is alpha carbon, this is a beta carbon, so this is beta keto acid. Okay, now what will happen in this case is when we heat this compound, this bond will go to this bond and go this bond of between carbon and oxygen atom will break itself to attack on this hydrogen atom, and as a result this hydrogen atom and oxygen atom's bond will be broken up to create a double bond between this carbon atom. Okay, and next what will happen is we'll also have this bond broken up between this carbon atom and this carbon atom, and this bond will be broken up and would be attached or rather formed between this carbon atom and beta carbon atom. So finally we'll be having something like this carbon and OH will be together. Okay, there will be double bond between this carbon atom and CH2, and CO2 will be released. Okay, so it will undergo tautomerism. Okay, and we will finally get a ketone. So this is the mechanism of this reaction. Okay, let's see another example wherein we have OH C double bond O. Okay, CH2 C double bond O and H. Again what will happen is it will take this hydrogen atom, oxygen will form a double bond between itself and the carbon atom. This bond will be broken up and would be formed between this carbon atom or alpha and beta carbon atom. Okay, so this is geminal dicarboxylic acid, if you have just noticed. So this is at this carbon atom and this carbon atom we have 2 carboxylic acid attached on the same alpha carbon. Okay, so this is example of geminal dicarboxylic acid. Okay, so we'll have something like obviously CO2 would be released, and then we'll be getting something like this CO2 would be released. Okay, and then we'll be getting something like COH double bond CH2 and OH. Okay, so what will happen in this case is again tautomerism will occur, and as a result we'll get something like this compound. Okay, a carboxylic acid. Let's take this example. We have CH2 over here, C double bond O here, oxygen and hydrogen here. So what will happen in this case when we heat this? Obviously we are heating this, so obviously this carbon atom will form a bond between itself and this hydrogen atom. Okay, and at the same time what will happen is this oxygen atom will form a bond with this carbon atom, and next what will happen is this bond would be broken up and would be rather this bond would be broken up and would be this bond would be broken up between this carbon atom and this carbon atom, and would be reformed between this carbon atom and this carbon atom. Okay, so we'll be getting something like CH3 here, single bond CH, double bond CH2. Obviously plus CO2 would be released, decarboxylation reaction we are seeing. Okay, so this is an example of beta gamma unsaturated acid. This is the alpha, this is beta. Oh, let me put it again. So this is alpha, beta and gamma. So we have beta, gamma. Okay, let me put it gamma like this: beta gamma unsaturated acid. Okay, again decarboxylation took place in this example as well. Now let's take a look at another example where we have a benzene ring and we have substituted OH on two adjacent carbon atoms of phenyl ring, so just like that, and now we are heating it. Now what will happen is dehydration will occur, and as a result we'll be getting something like this as the final product. Okay, so just to make it a point that vicinal dicarboxylic acid, which is the above compound, okay, on heating gives anhydride. Okay, let's look at another example where we have this compound, geminal dicarboxylic acid. Okay, so what would happen in this case is, on heating what would happen? So CO2 molecule from both the carbon atoms would evolve, and as a result we'll be getting a simple two hydrogen will be getting attached onto this carbon atom. Okay, and finally we'll be getting something like this as the final product. Okay, plus 4 moles of CO2 evolved. Okay, so with this we come to the end of this lecture. Okay, so, and in the next lecture we'll be continuing on seeing more examples of this type. Till then, good luck and goodbye.